Good afternoon, folks. So we're looking at logarithms today, and we're looking at mainly the conversion between exponential and logarithms. So essentially, what is a logarithm? So first thing you want to know about a logarithm is the fact that a logarithm is what we call the inverse of exponential. Okay. We started off with exponential already, but now we're going to start kind of intermixing logarithm with exponential. And the main thing about logarithm and exponential is called the conversion. And what a conversion does, it rewrites a logarithm using into an exponential or an exponential into a logarithm. So it actually does go both ways. But the base form for an exponential essentially becomes b to the x power is equal to the value of a. Okay. So essentially, this is what we call log base b a of a is equal to the value of x. Okay. That converts into base b to the power of x is equal to a. And it goes backwards. If you have base b power of x equal to a, then you can rewrite it as log base b of a is equal to x. Okay. Now, there's also something that I like to do this called there's really two versions of this that I've seen and used before. It's either called the rule 7 or circle rule, however you want to write it. But essentially, you start at base b, then it goes to the x, and then it comes to the a, kind of like that. So you write it where you start at the b, you come to the x, and then you set it equal to the a value, kind of like that. Okay, it's again called circle rule or rule 7, and it works both ways. Where I can start at the b, go to the a, come back to the x. So that way you write it as log base b a of a is equal to the value of x. Okay, so what you're going to be using is this log button that's right here is log. Okay, and then right below it says ln, natural log button. That's the other one we'll be using here in a second. So I'm going to show you how to rewrite and convert, and then how to do something called change of base form. So first thing is common log. Common log is a base 10 automatically. That's what most your number systems are actually written in, called base 10. But this can actually be written as log of x without having to actually write the base 10. So if it's log of x, it's understood base 10 automatically. Your calculator works in base 10. So this log button is actually a base 10 log. And there's different kinds of bases. You can have, base 2, base 3, base E, base, 1,000, depending on what you're working with. Okay. So to convert between the forms, again, if you use the rule 7 or circle rule, then, they'll both work. But you always start at the base number no matter what. So base 7, hold on, let me get my hand out of the way. Base 7 to the 2 to the 49. So in other words, I write this as 7 squared is equal to 49. And that's your exponential form. Okay. 2, 5, 32. So 2 to the 5th power is equal to 32. Log of 1,000 is equal to 3. So again, there is no log written. So automatically, that's going to be base 10. So 10, 3 is 1,000. Four to negative 3 is 1 over 64. Okay. So that's converting from a logarithm into an exponential. What about an exponential into a logarithm? Well, again, I can do the same rule. 525 is 2. So you write it as log base 5 of 25 is equal to 2. Log base 8 of 1 is equal to 0. Log base 3 of 1 over 81 is equal to a negative 4. Log base 12 of 2 root 3 is equal to 1/2. And that's how you convert forwards and backwards. Pretty straightforward. Now, if there are numbers in front, and by the way, we use this a lot for solving equations when we get to it, but a lot of times if there's a number in front, like what we call an a value, we'll have to do some other simplification first. So you can only do this if it's in one of these forms. Okay, if there's more to this than just this form, there might be some other things that we need to do and work through. Okay, so how does this help? Well, if I want to evaluate a logarithm, kind of like this, technology allows us to actually do this with the log base of 36. But again, if you don't have a calculator, here's what you can do. Okay, I can rewrite this as 6x is 36. And so you can actually figure out 6 to what power gives me 36. Well, again, if you know your squares, you know that x has to be equal to 2. Okay. So that's one thing that's good for is helping you determine values without having to actually use a calculator. 2 to what power is equal to 128. Well, again, 2 to what power is 28? Well, let's see. 1, 2, 3 is 8, 4 is 16, 5 is 64, 6, I believe, is 128. So x has to be equal to 1 to 6. Okay. And you can verify that. Or if I go 2 to the 6th power, should be 64. Oh, I went 1 too early. Sorry. 2 to the 7th power, I didn't add right. It's 128. So this is actually 7. My bad. What did I start with? 1, 4, 8, 16 is 4. 5 is 32. 6 is 64. And so, oh yeah, I missed the 5, I think, when I was counting this a minute ago. That was my fault. But 7 would be what you look for. Okay. Okay. So again, log of 1,000. So now, again, this is a base 10. So you can actually go, log of 1 over 100 and go -2. So we know that's going to be equal to a -2. Okay. 16 to what power is equal to 2? So 16 raised to the, it's going to be a fraction, that's for sure. So let's go 1 over 4 first. Yeah, there it is. To the 1/4 power is 2. So x has to be equal to 1/4. Three to what power? So 3 to what power is equal to 1 over 27? So this one right here is actually, and I should have done this one to show you also, because I know that 3 to the 3rd power is 27, then x has to end up being a -3 by rules of exponents. So negative exponents produce fractions like 1 over 27. So 3 to the 3rd power is 27. So therefore, 3 to the -3rd power is 1 over 27. Okay. 8 to what power is equal to 1? And again, if you know your exponent rules, x has to be equal to 0 because anything to the 0 power is equal to 1. Okay. Now, what happens if you don't know your roots, you don't know your powers, and things like that? So then we can do something called change of base. And change of base essentially says if you have log b and log a, you can convert that into log of a divided by log of b. And why is this important? Because if you had a base, or for example, if you have a base 5, unless you know how to use your calculator to do a base 5, then we can rewrite this as log of 34 over log of 10. And the reason why this is important is because you can actually plug that into the calculator instead, because this is change of base changes this to a base 10, which is what your calculator actually works in. So you can actually do log of 34 over log of 5 like this, and you get 2.1911. Okay. Log of 98 over log of 2 is equal to 6.6147. And again, I'm just plugging this in the calculator. Sorry. Just like that. Okay. Log of 4 over log of 20. That'll be equal to 0.4628. Log of 2 over log of 6 is equal to 0.3869. And again, this is all done in the calculator. The most important thing is knowing to change this into change of base to log 10 to be able to plug into the calculator. Now, again, with technology, there is a log base button, but we also do this at times to actually be able to solve the other equations. So knowing change of base helps with solving other equations down the road. Okay. All right. Last thing, natural log. So natural log. So log with the base of e to the x is the same thing as saying ln of x, natural log. So there's a button right here that says ln. That's the one I'm talking about. Okay. So if I want to rewrite this in exponential form, base e to the fourth power has to be equal to x. Okay. Base e to the x power has to be equal to 10. I want to rewrite this in logarithm form. You could write this as log base e of 50 is equal to x, or you could write this as ln 50. This is the one, equals x, sorry. This is the most common one that you see. You really don't ever see it like this. Okay. So log base e of x is equal to 0.5, or ln of x is equal to 0.5. Okay. Again, this is the most common one right here, natural log, ln. Approximate natural log of 64. So again, ln, natural log, 64. It's roughly 4.1589. Ln of 1/3 is approximately negative 1.0986. Okay, just showing you what I'm doing on my calculator. And that's that. That's a conversion. That's different change of base properties. And again, we'll use these later on to actually solve equations, but just want to start kind of giving you the ideas how to use them. All right. You all have a good afternoon.